semester. Thank you for your cooperation. And next week we will have our final exam. All right. By the way, I would like to make a questionnaire. Well, just ask. Do you think this course taught in English make it difficult? Is that make it difficult, even more difficult, or it's okay? No matter I use Chinese or English, this is difficult anyway. What do you think? Do you think this course will be easier if I taught in Chinese? Please raise your hand. 1, 2, 3. 1, 2, 3, 4, 5. 5. Okay, 5. So do you think it doesn't make any difference? English or Chinese doesn't make any difference. How about that? 1, 2, 1, 2, 3, 4, 5. Oh, 5. Okay. 5. So 5 on 5. Interesting. Good. Thank you. Good. Okay. So it's just nice to hear your voice, hear your opinion. That's good. Thank you. Thank you. Or does anyone use OCW in Chinese version? 1, 2. So which means that you feel that so OCW in Chinese version actually help you. Do you think? 真的有帮助到你 OCW 中文版？不好意思，不好意思，我耳朵很差。比较赶，我比较赶，你比较赶。但是我有英文版，所以英文版跟中文版你就会选中文版啊。你呢？你跟他一样，所以其实不是因为英文版听不懂，而是因为有英文版跟中文版选，你就选中文版这样子。然后反正你是要看影片的话，你就会选中文版，这样是这样意思吗？可以2倍速，英文版也可以2倍速啊。所以我吗？Sorry, I can't do that。所以中文版，英文版也可以2倍速啊，但是英文版2倍速就听不懂，对不对？但是中文版就可以2倍速，所以还是听得懂啊。那再问几个问题。如果是英文版的话，这学期的英文讲课有让你学到新的英文单字，或是新的？我说新的就是例如说 prismatic 有。那有没有其他的？就是有没有学新就是因为英文版而学到中文版而学不到的东西这样？有啊，我知道讲数字啦，000 273 5505之类的，对啊。所以还有什么特殊的意见？就例如说，请不要 EMI，还是你觉得还可以啦？就是有没有什么其他意见？对，因为我不知道为什么啦，就是有很多老师就是会请我去分享 EMI 的课程的教法什么，然后就是我到最后都会有一个问题，就是说台湾到底适不适合使用 EMI 课，就是教学这样。那我自己是觉得没差啦，就是要我教 EMI 我就 EMI 啊，大概是这样的哈。那所以说我如果要去分享这些东西的话，我就必须好像要说服自己说，一定要 EMI 哦，然后怎样。那我就想要就是让学员告诉我一些意见，这样。那我觉得也蛮有趣的啦哈。那我是觉得讲 EMI，我在这学期讲完以后，我觉得对我来说并没有太大的改变，我反而觉得我讲的更慢了。因为我讲英文我会讲很慢，没有中文讲那么快。 然后我讲英文的话，我的表情跟嘴巴我会变得更夸张。比如说，我每次看我自己的那个影片的时候，我都会觉得我自己在讲英文的时候，我会变这样，这样，所以我有这种表情。但是我如果中文的话，我就的，所以我不知道这样子的表情，就是我会为了要让英文讲更清楚，所以我会有那样子的表情，跟讲话的痛调跟速度这样，反而好像我自己觉得好像反而比中文还要更清楚，我自己觉得啦哈。所以我不知道有的时候，像我上完这门课，我这一次是我第一次来在材料力学，那我自己是觉得好像没有心中想的这么的困难，对，这是我自己的感想啦。好，OK， so let's continue our lecture. So last time we talked about the plane stress and plane strain uh, comparison. Okay, again, a very important, very important concept is that plane stress is the stress without with any z subscript equal to 0. Okay. However, their epsilon z is non-zero. It's non-zero. Okay, because of the Poisson ratio effect. Then, plane strain. The plane strain is that the strain may have non-zero. Sorry. The plane strain is strain with z subscript. They are 0. Okay. However, because suppose if you have the epsilon x, epsilon y, which means that you have the z Poisson ratio effect. However, the epsilon z equal to 0, which means that it naturally has the stress along z direction to cancel each other, to make the epsilon z equal to 0, right? So sigma z is non-zero. So these two terms, you need to be really careful, okay? And we also want to emphasize that plane strain is suitable for describing the material with the long z-axis, because even if you have a tiny deformation along z direction, but because the original length is really long, so the strain epsilon z will approximately to 0, right? So that's the case. And then very similar to stress, plane stress, we need to determine the transformation equation for different plane. Okay, epsilon x, epsilon y, gamma xy is our known. And then we need to see these three strain, epsilon x, epsilon y, gamma xy, can contribute the epsilon in x1 direction. So this is the first arrow displacement due to the epsilon x times dx. And this small arrow is the displacement along x1 due to the epsilon y dy. Okay, and this small arrow is due to gamma xy dy. Right? So three contribution together, and you can relate epsilon x1 to the three known value, and then you can obtain epsilon x1. Okay, that's it. Next one, last time we stopped here, right? We want to calculate the gamma x1 y1. The gamma xy y1 is a little bit difficult, more difficult than previous page. So you can imagine that your x, y is your original coordinate, and then your x1, y1 is your new coordinate. And if you want to determine the gamma x1, y1, means that your x1, y1 h will change their angle. So for example, gamma x1, y1, So if you change the alpha x1 toward AH, y1 toward BH, you have alpha and beta, and alpha is counterclockwise, and beta is clockwise. Okay, and when they sum it up together, alpha plus beta means gamma x1 y1. Okay, so your alpha, let's determine alpha and then determine beta, right? So alpha x1, let's see the x1 x epsilon and y epsilon and gamma xy can contribute to alpha in counterclockwise. How much? Okay, how much is the contribution due to the epsilon x, epsilon y, and gamma xy? So the first one, if you change the epsilon x dx to the right hand side, and it will make this x1 to with this angle, right? The angle is this little arrow here. The arrow here is we need to use the this tiny pink triangle to get the h here, epsilon x dx sine theta, and this green value divided by ds will be the small arrow change, angle change here. So you see green divided by ds is the angle change in this small small pizza shape. And then you notice that here I gave you a minus sign. Oh, minus sign means that here this epsilon x to the right hand side will make this x1 go clockwise. But now your alpha is counterclockwise, so they are opposite side. So you have minus side here. So you need to be really careful about this because how to draw this, I don't know. Well, you see that this minus side is because this is counterclockwise and this is clockwise. So this minus sign, okay? And then similar example can be C. Okay? Oh, sorry, not this one. Ooh. Okay, so you see this point because will go up because of the epsilon y dy. Boom. So your point, x1 point, go here. So the angle change will be this small angle. The angle here is counterclockwise. So here, positive, clockwise, counterclockwise, positive, positive. This is okay, right? So how about let's take a look. What is this value? This, oh, sorry. This value is epsilon y dy cosine theta, right? So it should be in blue shape, okay? Blue shape. Epsilon y dy cosine theta divided by ds. So this is the angle it contributed to gamma x1, y1. Sorry, alpha. Okay, this is alpha. Next one. Next one is similar. We can do. Okay, you see this point will move to this point. Okay, this point will move to this point because of the gamma xy twist, right? So we need to get, again, the value here is gamma xy xy dy sine theta, right? So this is, I'll go for purple, maybe. Purple. It looks similar. Let's change other color. Ooh. Okay, brown. Okay, brown value. This is brown value. Gamma xy dy sine theta divided by ds will be the small angle here. And you see the small angle here is clockwise. So again, minus side. Okay, minus side. All right. So for alpha, sorry, x1, sorry, epsilon x, epsilon y, gamma xy can give 3 contribution for alpha angle change. And then you get this ugly value. Alpha equal to ugly value here. Ugly. All right. And then that's it. How about beta? Do we need to determine this one again to get beta? No, because the same trick, we have done that before. All we need to do is substitute theta plus 90 degree, and then add negative sign here, because beta is clockwise. Okay, you see, all we need to do for beta is we just assume the y1 is a new x1. Okay, so we just substitute theta here plus 90 degree. However, you see this y1 is actually clockwise, but your alpha is counterclockwise. So you need to add minus sign to your original value here to get beta. So your beta is theta plus 90, theta plus 90, theta plus 90, and with the minus sign, add it up. So positive, positive, you see, positive, positive. All right. So you got another ugly value here, alpha and beta. Finally, gamma x1, y1 equal to alpha plus beta, blah, 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 blah. Okay, ugly, I know. This is ugly. However, if we rearrange a bit, and we can get to next one, in next page. Again, the square things, you can use it, use your double angle equations, I don't know, 背角公式, to make it look simpler. All right. You understand what I'm talking about? Okay, good, very good. So we have gamma x1, y1. So next one, we will use double angle equations, and then we can go for next page. So plane strain transformation equation. Wow, it shouldn't conversion. Sorry, it should be transformation. Transformation equation. Okay, transformation equation. We use double angle for the cosine and sine. and then we can have epsilon xy, blah, 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 average of epsilon x, epsilon y, and difference divided by 2 cosine 2 theta, gamma xy divided by 2 sine 2 theta. And gamma 1 y1 divided by 2 is this one. Okay, so basically, well, it's really similar. And then epsilon y, of course, all you need to do is adding up, substitute theta equal to theta plus 90 degree. You can get epsilon y1 again. So you can notice that epsilon x plus epsilon y equal to epsilon x1, epsilon y1. Very similar to stress invariant. Here is strain invariant. 不变量 ，OK， 应力不变量，应变不变量 ，OK。So the sum of the normal strain or of the stress element does not change due to different coordinates. Yeah, that's invariant. So I believe you will predict what will come next. What will come next? Principal strain. Maxima shear strength, right? Because we have sine, cosine, sine, cosine, right? So what we do is find the principal strain. We differentiate with respective to theta and then set equal to 0. And then we can get a tangent to theta p equal to blah, blah, blah. And then you do exactly the same thing. And you can get principal strain equal to this one. Plus and minus. Do you think this is really similar to a Mohr circle? Very similar. This is R, right? Plus and minus R. And this is the origin. Very similar. So what you learned previously, today we can go really fast. Maxima shear strength. Maxima shear strength. Again, gamma x1, y1 divided by 2. And we do differentiation respective to theta and then set to 0. And then you can get this one and this. Yeah, very similar to R, right? Very similar. I just say very similar. And principal plan and maxima shear strength plan with the 45-degree angle, exactly the same. Exactly the same. And you can imagine that principal plan strength, Mohr circles, it's really similar to what you learned in plane stress, Mohr circle. And I want to add in the arrow here. Okay, epsilon x1 and gamma x1 y1 divided by 2. Okay, again, I want to make it highlighted. Okay, epsilon x1 go to right hand side as the positive direction, and gamma x1 y1 divided by 2 go to the downward as the positive direction. And so you can see substitute sigma x1 with epsilon x1 and tau x1 y1 with half gamma x1 y1. Okay, I guess this is a little bit need to be careful about is this half. Okay, this is half. Because I believe you know that the gamma actually come from two axes. X1 angle change, Y1 angle change, right? So your tau x1, y1 is just one shear stress, but your gamma come from two contribution. You need to divide by 2. Okay, you can just think, use this to memorize it. 就是我刚刚说这边除以2就比较特别要小心一点。那其他都一样，除了这边要除以2。那大家可以想象一下，就是我们的 gamma x1 y1 当时在算的时候，记不记得它是用 x1 的贡献跟 y1 的贡献，所以我们把它除以2，就是它才比较，我们可以靠这来当做我们的记忆帮助我们记忆。Okay, so if you can understand that, we can just straightly give you a example. Consider the plane strand stay shown in figure this one, okay? And then the figure has X direction. The 340 times 10 to minus 6. Very tiny strand, okay? And Y even tinier, 110. And the angle change is 180 times 10 to minus 6. Okay, so this is what they gave. And they want us to find the strand element at theta equal to 30. Okay. Ooh. Wow. I don't have. Okay, anyway, I will try my best to fit it. Oh, well, I will add in one more page for the next. I'm sorry. I forgot to give you a blank page for that. And yeah, and the principal strand and gamma's mix happened, occurred, and sketch the corresponding element. Okay, so let's do it. Oh, by the way, do you know now you can just screenshot this and then feed into ChatGPT 4 or and then it will solve for you. Do you know that? 你知道吗？你只要荧幕截图这个，然后丢到 ChatGPT 里面，然后就给你答案了。不然我们来现在试试看，然后就不用教了。哎，不能截图啊，因为这是投影啊，没关系，我来截图一下，让我们来玩玩看啊。可是我没有ChatGPT for all，不好意思，我没有，对我还没有付钱，试用吗？哦，一个头，好，那我来试试看，我们来玩玩看啊、哦。看得出来今天做的历时间很多嘛，对不对？啊好，来我们来试试看，尤其是这种简单的例子。So short, and then let's go for Chat GPT. So I just want to say ChatGPT 4 is for all can solve the problem immediately just by screenshot. Very slow. Come on. Way too small. Way too slow. Do you know that? Screenshot and solve your math question. Do you know that? 你们知道吗？你们都知道了吗？不知道，刚这是骗子，怎么可能？你们应该比我更早知道这件事吧？还要我教你？还要我教你作弊吗？OK，太慢了吧？可能是我现在在录影啊，或什么之类的，上传这些线上课程之类的。哎，这太慢了吧？算了，你看 AI 真的很逊吧？还是我来好了。好了，我先解题好了，解完题我下课的时候我再来玩。Okay, sorry because it's too slow. So I think I think I'm better than AI. So let's go. Okay, the first one. Epsilon x plus epsilon y divided by 2 average. All right. So 340 plus 110 times 10 to minus 6 divided by 2 equal to 225 times 10 to 6 minus 6. And epsilon x minus epsilon y divided by 2 equal to 340 minus 110 times 10 to minus 6 and divided by 2 equal to 115 times 10 to minus 6 gamma xy. However, nothing needed. 90. Okay, so when a theta equal to 30 degree, so epsilon x1 equal to 225 plus 115 cosine 60 degree plus 90 sine 60 degree times 10 to minus 6 equal to 360 times 10 to minus 6. Epsilon y1, easier way to do that using strength invariant. 90 times 10 to minus 6. How about gamma xy? 1 divided by 2 equal to minus 115 sine 60 and plus 90 degree, sorry, cosine 60 degree times 10 to minus 6. Too crowded. Okay. And equal to minus, sorry. So your gamma x1 y1 equal to 1 minus 110 times 10 to minus 6. Okay, just substitute all the value. Okay. And now you can imagine that yeah, you can just draw the figure. So this is x, this is x1, and this your y1. Okay, and originally it looks like a square, and then after the deformation, this is 30. Sorry, 30 degree, and after deformation, you see epsilon x1 equal to 360 times 10 to minus 6. So 360. So this is 360 times 10 to minus 6. So you can imagine that it elongates across, along the x1. How about y1? Y1 is 90. 90 is relatively small. So you can imagine that this line will increase 90 times 10 to minus 6. So here, it will be 90 times 10 to minus 6. And then you can see that the gamma x1, y1 minus 110 times 10 to minus 6. And also you see this is minus, okay? Minus so let me take a look. So you see 90 previously this is 90 times 10 to minus 6, right? So which means that your angle subjected to a positive shear strength. So your shear strength make it become a sharper angle. Now you go to minus, so which means that your 90 degree become greater. Okay, so it will make the so it will make 90 even greater. So here is 110 times 10 to minus 6 radian, not degree. Okay, this is radian. Right. So now you sort of make the x to this position, y to this position, and your angle become this. Okay, so all you need to do, the new element, sorry, not new element, the element after deformation can be looks like that. Just connect them. Okay, connect them. Okay, that's the result. Okay, so the meaning of this one is that the actual meaning in the overview, in the macroscopic view, is that if you have a potato material looks like potato. Okay, if you have a potato material, new material, okay, a new material looks like a potato, and you draw okay, you draw a square on it, and you use this material subjected to whatever load. I don't know, I don't care, but just saying that this material is subject to whatever load, and it makes the blue square become the one you see in your problem. Okay, after this yellow load, it becomes the green, the lighter blue element shape. So, which means that if you draw a this one with 30° before the load, okay, before the load, please imagine that this one and that one at the same point. Okay, I'm sorry because I cannot draw that as close as possible, but they actually at the same point. Okay, so if you draw this and you subject to the same load, okay, and you will obtain, you can make this blue shape twisted like what you draw. So this is the meaning of what we determine here. I guess you guys, I guess you understand what I'm talking about, right? Because it is a simple concept. All right. Next one, principal strand. The principal strand here is that B principal strand. Right, let's continue. So epsilon 1 and 2 equal to, remember the what's that? Mohr circle. Average plus and minus the R. The R is a little bit ugly. Epsilon x minus epsilon y divided by 2 plus gamma xy divided by 2. Okay, so 2 to 5 times 10 to minus 6 plus and minus 115 times 10 to minus 6. 2 plus 90 times 10 to minus 6. 2. We need to elongate the. Okay, so our epsilon 1 and epsilon 2 is the greatest one will be the epsilon 1. Okay, so 370 times 10 to minus 6 and 80 times 10 to minus 6. Okay, we get it. We get it. And then we are going to draw a element, stress element for that. However, we don't know what is the theta p, the angle here. So let's go back to our original, sorry, 2 theta p. 2 theta p gamma xy divided by epsilon x minus epsilon y equal to 0.7826, and theta p equal to 19.0 degree or 109.0 degree. Okay, so which one is for that? We don't know. We just need to substitute the equation. Okay, we substitute the equation and then we can get, oh, okay, the theta p, the 100, we substitute, well, we substitute the angle to the equation. Okay, and then we can get this one. 19 is for 370. We substitute the value. Okay, and 109 is for 80. All right, so we substitute the theta and we can get, we can know which one. Okay, so which means that we are ready for how can I? Okay, I just make a rune for that. So 90 degree, 90 degree. So this is X, and this is X1, and this is 19 degree, 19 degree, and it will looks like a square before the deformation, and this is 370 times 10 to minus 6, and here is 80. This is 80 times 10 to minus 6, and all we need to do is connect them. Connect them. Okay, that's it. And do we have the shear? No, because this is maxima principal strain occurs. So all the contributions go for normal strain, no shear strain at all. And then I guess it's time for break. And then after we come back, I will continue to determine gamma mix. All right. So if you have any questions, just come here. And if you have any question about the sheet, exam sheet come to teaching assistant. That's it. Thank you.
这一个就是有一块一点点。
哎，
就是这个叫 Julius AI，你把助理图你丢给他，基本上都可以算给我。
真的假
我
？Julius，OK，好，我去找张相，
我刚截图给他，
对，
然后他就算出来，
然后答案是对的吗？
都对。
都对哦，太强了。
可是他不会有，他详解释，就是他是用 Python 写的，他是会有详解，他只会有正确的答案。
哦，哇，哇，超帅的，
就基本上只有答案
是可以看得懂的。
对。
好，我们来试试看 ChatGPT 4。Julian。Julius AI， 好，真感谢。那我们来，test， 不理我哎，大家可以下课哦，没事，我们在玩而已。Bad gateway。等一下，ChatGPT 是当掉了吗？是吗？真的啊这么衰啊？好吧，我已经重整了啊。对啊，我用手机版的。嗯，哎，真的耶。哎，
我接到他就在聊了，
嗯
这帮我整理准备了一定准备。所以才错。对，这个因为是都要以前的朋友可能到时候，但是也是很正常。就是几个这样讲两次去，我是我现在我反正两个这个是我来自己爱情的关系，主要是那个时候在就我们身边嘛，我是边上去的，如果不是我们提的人，中国是我是因为我的人讲，然后因为那个是在我们，因为我是。是说是我的人的，那我觉得是还是一般的，然后他主要是我的是问题，你有什么想法？要从这个来是我把自己会不会去的招来掉，我去了什么事情啊？那你我去。好像我觉得，其实应该全部东西也不少。
哎，时间好像到了，让我们快速的结束这一学期吧。喂，不好意思，ChatGPT 好像宕机了，大家回去可以试试看。然后刚刚同学跟我分享，Julius 好像 Julius AI 就可以直接把刚刚那个截图截下来就可以放上去，然后它还 generate Python code 把答案画出来。虽然他画出来的它只是方向啊，把那个角度画上去，但是终究还是我画这个才是比较正常的啦，大家才看得懂这样。那他就只画了3个方向，例如说什么30度啊，不知道几度啊，这样画三个线这样。那答案真的是对的，然后我觉得还蛮酷的。但是我在家里自己测试其他的例题啊，不是材料力学的其他例题。结果我就发现有一些比较复杂的题目就会算错，他就是说，但是他却表现的他好像还是很会的感觉，他就转成出来，然后答案是这个。哦，真的吗？所以你们都试过了嘛？那你刚刚还跟我说你不知道，公数应该没有问题吧？真的吗？矩阵运算啊，我一知道这件事情，我就马上想到工程数学。工程数学的那个矩阵啊，那个 vector 啊，那应该都很明显，它就是一个数学。但是我们材料力学有一个问题，就是它会从应用的题目，然后到数学，然后再解题，所以这其实比较难。那我有去尝试把那个，例如说第4章的那个飞机的那个叫什么那个什么简历弯曲图，对，记忆的连环套上去，他就他就乱算一通。哎，不过没关系，反正就试试看。Anyway, I just talk about the ChatGPT may not give you a correct answer, although it pretend it could. So you need to be really careful. Don't trust AI. Trust yourself. All right. You need to re-examine, double check the answer provided by AI. All right. Although the AI certainly can give you some hint. I guess. Yeah. Let's continue. All right. So I will give one more page. Okay, do that. One more page. Okay. One more page for gamma. Uh-oh. Right, so gamma. C gamma mix. So what's gamma mix? Gamma mix is theta s equal to 90 plus 45, right? So 64 degree. And the other is or 19 minus 45 become a minus 26 degree. So you can imagine that you can just draw a figure here. And okay, and this point, that point, and this is theta p equal to 1 is 19. Theta p equal to 2 equal to 109 degree. And this is theta s equal to 64 degree. And this is theta s equal to minus 26 degree, right? I guess you understand this. And then By using this, you will know which one is the maximum gamma makes gamma x1 y1 divided by 2. Which one? This, right? So this one can be a, well, can be the maximum, well, the positive gamma mix. All right, so let's continue. Gamma mix divided by 2 equal to the R. Okay. Epsilon x minus epsilon y divided by 2, the square, plus gamma xy divided by 2 square equal to 146 times 10 to minus 6. Okay, so yeah, you sort of know that. Okay, and then we are ready, some sort of ready for x and x1, and this is 64 degree, and this is y1. Okay, and previously it looks like a square. Okay, and what else? Let's rearrange a bit. Okay, and then however, when gamma mix occurred, the epsilon x1, epsilon y1 is non-zero. Okay, so epsilon x1 equal to x1 plus epsilon y divided by 2 plus epsilon x minus epsilon y divided by 2 cosine 2 theta plus gamma xy divided by 2 sine 2 theta equal to 225 times, oh, sorry, I forgot to let you know. Actually, this theta should be 64 degree. Okay, because you know that a 64 degree, well, yeah, that's what you're going to get, right? 64 degree. And you can get 225 times 10 to minus 6. So 225. Although you can see that this is the actually exaggerate deformation. You see 10 to minus 6 is a really tiny number. So in the real world, it just a little bit deformation, just a little bit. Okay, epsilon y1, epsilon x plus epsilon y minus epsilon x1 equal to 225 times 10 to minus 6. Okay, so again, another 225 times 10 to minus 6. Okay, that's it. Wow. Okay, right. So how about gamma mix? Gamma mix is 146 times 10 to minus 6. Oh, they are divided by 2, so need to double it. Okay, so double it, and this is let me take a look. Oh, so you see, this is 64, right? 64 degree. So it is minus, it's in the top of the circle. So this is minus 146 times 10 to minus 6 times 2. Okay, so it's still making the 90 degree bigger. So yeah, that's okay. 292 times 10 to minus 6 after the double, right? So that's it. That's it. Ugh, ugly, sorry. Okay, that's it. Right, so this is the answer of the second part. Right, that's it. Okay. One more thing I want to emphasize here is that in your exam, you can, for example, it's just a supplementary. Okay. So when you are plotting the shear, when you're plotting the shear strength, suppose you may, for example, okay, suppose if you have a shear, you can do, for example, you can draw after you determine the value. Okay, you can draw like this, or you can draw, you have several choices. Okay, you can draw like a this. I should use red. Okay, so which means that you can make it one, I mean double or half. Okay, so in your exam, you can draw like this. Okay, you can draw like this. They are all similar. The only difference is that you accumulate two half gamma x1 y1 into this place, or you draw half gamma x1 y1, half gamma x1 y1. Okay, so actually they are similar. They are equal actually. Okay, in your exam. So when you draw this in your exam, yeah, I should say in your exam, in the exam, you can either draw left hand side or right hand side, both. Okay, but if I were you, I would choose this one. Okay, because it's easier for you to change in x and the y, right? But here, well, x. It's really difficult to draw. It's really difficult to draw a. It's really difficult to draw the x direction and y direction in the second case. So I prefer this one. Okay, but they are the same. They means the same. I hope you can get it. Final topic in this material mechanics of material course. Great. And the final one, sorry, any questions? 你说没差. Good questions. Yes. Well, one more, since you mentioned that. Good questions. a you can also do this one. Well, anyway. Okay. You can do that as well. Okay. Right. But I will still prefer this one, left hand side. All right. So that's it. Final topic. Final topic is, I guess, is more practical. I guess you will use that sometimes when you are doing your experiment, which is strength measurements. When you are going to use, where you are going to use a strain gauge. I believe you heard of strain gauge. Strain gauge is a tiny device with a circuit or resistant on it. And then if the strain gauge changes its length, it will change the resistance of the electrical resistance of this device. So if you measure that device, the resistance value, you can have the corresponding strength value. Okay, so it's really, it is a smart invention. Okay, so next one, we were going to let you know 3 strain gauges can give you all the information for the strain analysis you learned in chapter 7. Okay, 3 strain gauge. Next one, 3 strain gauge. Next semester, sorry, next year in this course, I may ask ChatGPT for to teach the course next time. So you can encouraging your junior 学弟学妹 come to this course, and then you can learn. I guess I will include ChatGPT 4 to help me. Maybe the idea in my head is that because ChatGPT 4 can solve certain problems, certain simple problem, but difficult problem, ChatGPT 4 may need your help. So maybe our learning activity will be try to lead ChatGPT 4 to solve the problem. Sounds good, right? I don't know. I will try several examples, and if it does work, I will introduce to our next year. Good. Next one. Strain measurements. 3 strain gauges can measure normal strain. Oh, strain gauge can only measure normal strain, of course, because it is really difficult for a strain gauge to measure the angle change, right? It only can measure the length in original length and then elongation or compression, right? Only normal strain. So you need to use the plane strain transformation equations to obtain all the strain component in any direction. Okay, so that's it. So you see, typically the strain gauge will attach 90 x, y, and 45 degree. Okay, and then you can use the transformation strain equation to obtain its gamma. Right, so that's exactly what I'm going to introduce in this page. You know, epsilon A, epsilon B, epsilon C are known. And A, B, C are the strain gauge. A and B and C measured value. Okay, and it asks us to determine epsilon x1, epsilon y1, gamma x1, y1 at angle theta. So this example actually asks you to show the procedure, prove the procedure, show the equations, transformation equations for this case, 45, 45, A, B, C. All right, so luckily, epsilon x equal to epsilon A, epsilon y, yeah, epsilon y equals to epsilon C. So how about gamma xy? We don't know, right? We don't have that kind of a strain gauge. So all we need to do is use the help with the help of the transformation strain equation. And then we can get so at 45 degree, epsilon x1 will equal to epsilon b, right? Gamma xy. So our epsilon b is epsilon a plus epsilon c divided by 2 plus epsilon a minus epsilon c divided by 2 sine 90 degree plus gamma xy divided by 2 sine 90 degree. And yeah, that's it. So you can learn that epsilon b, gamma xy equal to 2 epsilon b minus epsilon a minus epsilon c. So that's the value we usually used, right? Epsilon x, epsilon y, gamma xy. We usually use that. So no, so then the real question is, what is epsilon x1? What is epsilon y? And what is gamma x1, y1? But now I guess you know how to do that, right? We can just substitute all this, okay? And then we can obtain epsilon xf1, epsilon y1, gamma x1, y1. That's it. So the most important part is here. Gamma xy is 2 epsilon b minus epsilon a minus epsilon c. But don't memorize it. Don't memorize it, because in the exam, typically we will give you certain like example one. This is example one, right? And example two. What is the example two? They will start to give you something like that, right? Right. And so maybe this is 45 degree. And this is A, B, C. So how can we do? It doesn't fit this anymore, but it's okay. All we need to do is we just move this one to here. And then we can say, oh, this direction is actually 135 degree. And then you can follow exactly the same procedure, and you can get the gamma xy equal to blah, 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 blah. Another classic example is square triangle. Okay, and this is 60° for each angle, and then you can get, it will be even more difficult, more complicated, but you know how to do that. This is 60°, right? And this is 120°, and this is X. So that it will be more difficult for this one, of course, because here you need to find a way to get the epsilon y as well. But the concept is really similar. Okay, that's it. That's all for the semester, for this semester. I thank you for your contribution. Sorry, cooperation. Maybe, yeah, you have some contribution. Thank you very much. And anything else? I quite enjoyed teaching this course in English. Surprised me because I thought it would be really difficult. I thought it would be really difficult to taught this course in English, but turned out it sounds okay. Right, and maybe you found that I upload chapter 9 on the shared folder. You can download that and see it. Well, it will be the advanced topic. Typically, if we have time, if we taught in 18 weeks, I will have chance to reach out chapter 9. But unfortunately, we don't have that time. So we only stop at chapter 7. So the final exam range will be 4, 5, 6, 7. Okay, 4, 5, 6. Sorry, 4, 5, 7, no 6. All right. That's it. Any questions? If not, I will thank you and goodbye. Bye-bye. If you have any questions, just come here. 上课啦，没啦。So, no course for today. So no course for tomorrow. Start right now. Stop right now. Thank you. Bye.